Yeah, I can just start now. Hi, I'm Ayaka. I work for Big Switch Networks, which is a software development company that does data center traffic management and monitoring applications. And I guess I'm an OpenBSD user by hobby. Actually started looking at OpenBSD after hearing Ryan's talk about OpenFlow on OpenBSD at the SDN. So I guess my company is about a tool called Mininet. It's a software-defined networking, capable network modeling tool. So it runs networks so that you can kind of experiment with them. And there's a couple of companies and several universities actually that sort of use it for SDN-related development and other stuff. And because OpenBSD has open source support and a SDN stack, I figured it would be kind of nice or maybe even useful to have it like runnable on there. So I'm going to talk about how I import it. But before I begin, SDN is kind of a buzzword, so there's like 5 billion different definitions. It's whatever makes money. So I'm going to kind of define what I mean by that. So when I say SDN, I kind of think about a traditional network, which is a bunch of switches and routers. Each of them has their own network management interface. They might have 50 switches, and then you might end up with like 50 SSH sessions, or usually probably telnet because switches are kind of 20 years behind everything else. And SDN, which stands for software-defined networking, sort of tries to take that management interface and turn it into a programmatic one, and then it exposes this control channel. And that control channel is used to program the switches or data paths to behave however you want from the control plane. So the control plane is usually made up of one or more controllers. Those are just regular applications that run on commodity hardware. So the idea is that you have these controllers defining how they want the network to handle the traffic. And the idea is because they're running on much more higher powered compute than what the switches are capable of doing, you can make much more sophisticated traffic manipulation schemes. And I guess another interesting part about SDN is because you have these, the network intelligence in a set of programs running somewhere, you can actually kind of poke at those programs to sort of get the idea of what the network as a whole is doing, almost as if it's a single entity, like a logically centralized machine or something. And that's kind of like the happy ideal case with SDN. The reality is a bit different. But now if you have a controller, you can almost kind of expose this northbound API, and from there you might be able to create traffic engineering and routing applications that work with the full topology as a whole, or the full network state. You can also have like a CLI that's just one point of entry as opposed to 50 different sessions. There's 50 different CLIs. So the control plane connecting the control channel connecting the control plane to the data plane can be implemented in several different ways, but one of the poster children of SDN would be the OpenFlow control protocol. It's a openly standardized protocol that was initially designed at Stanford during the clean state networking program. Currently, it's a thing that's being maintained by the ONF, or the Open Network Foundation. It was designed for programming Ethernet switches at first, but it's been a while. I think the current spec is at 1.6, and it's grown in capacity considerably. So now it might also do like optical devices like modems or label switching. So like dealing with VXLAN or MPLS, or I guess VXLAN is a different switch. But anyways, so the kind of idea behind OpenFlow is you have this basis called the flow, which is a traffic class that's kind of defined by a certain header pattern and a certain certain kinds of metadata, like input port. And each of those flows are matched together with an action. So like say drop a packet or output through these ports or those kinds of things. And that's kind of one flow rule. So how the controller uses OpenFlow is it would create these flow rules and package them into these flow mod messages that get pushed down the switches into the flow tables, where the switch, when it sees traffic, would kind of try to match it up with whatever is in its flow table entries and try to apply the actions to it. And that's kind of how the programming is done using OpenFlow. So certain kinds of rules depend on what the switch is capable of or what kind of features it has. So those kinds of features are discovered through the initial handshake between the controller and the switch to establish the OpenFlow control channel. But afterwards, there's also a set of messages that can be used by the controller to query the switch. So again, OpenBSD has had a SDN stack that speaks OpenFlow 1.3. It's been there since 6.1. And there's 3 main components. Switch is the driver that enables you to create interfaces that support OpenFlow. So basically, that's the data path component. So each switch interface is associated with a control channel. It's a special character device. So if you have a switch 0, you would have a dev switch 0, which is its control channel. And the control channel gets, on the other side of the control channel would be switch D, which is the controller. It's a fairly minimalistic program. So it has basic S-flow manipulation, traffic forwarding capabilities, but connection between a switch D and a switch are kind of this self-contained pair that kind of makes switch into a forwarding interface. But sometimes you would want to have an external controller that you want to point a switch instance to. So switch D is also capable of relaying the control channel to that remote target. And in order to configure that, you would use switch CTL. Also, there's a switchd.conf that you can use to have preset configurations. So I guess because of how SDN as a network design approaches, you have multiple different components that are relatively standalone. So even if you were developing a switch that's capable of OpenFlow or something, you might not be the one that's also developing a controller. Both the switches and the controllers can kind of test it separately. So at a certain point, you want to also see how your component can interact with the full SDN stack. So if you have a switch, you want to test it against like several different controllers or vice versa, or what kind of topologies your controller can handle. So what you can do is, you might build a hardware test bed, which turns out to be kind of expensive, maybe if you do it yourself. You might also have a test bed because your university or someone might have something like Emulab or be part of Genie, which is like a larger scale, realistic network environment. But then you're sharing it with other people as well. So you're kind of working with your time slot. You might not always be guaranteed a time slot you want. You might not also get the resources you want. And if you want to test out different kinds of scenarios, like different topologies, it gets kind of cumbersome because at the end of the day, you might have to set up a bunch of tunnels or move around a physical wire. So a lot of the cases, until it kind of reaches a relative late stage point of development, people tend to say, I just want something that emulates the behavior of an SDN stack well enough, but I also want the flexibility to just kind of test out different scenarios for the time being. So I'm just going to try to emulate my networks or have different test scenarios. And that's kind of what Mininet caters to. I kind of just took that first line from the website. So it just describes itself as an emulator for rapid prototyping software defined networks. So there's two main ways that people tend to use it. One is the mn command. It lets you quickly launch different kinds of topologies, very basic sanity tests for your switch controllers. So, for example, for your controller, you might be like, okay, the baseline behaviors, I want to at least be able to have it forward. So you might have a ping type of test. Or if you have a switch, you might want to see how much throughput it can handle. So you might want to set up 5 perf sessions or something like that. And then it's a command that kind of lets you launch topology and launch test cases. The topologies that it kind of has are sort of templates that are parameterizable. But you might also want more customized test scenarios or topologies that model something more realistic, in which case you'll use the Python packages that Mininet provides to kind of stitch together your own setups. It also has a few other features like a CLI you can actually attach to your topology, so you literally get this prompt where you can say, give me all the nodes or give me all the links, and kind of do a bit more manipulation. And if you don't want to script something, you can also drag and drop a topology and have it kind of create the script for you. But usually the case is people more often use a comp3. So kind of to give a better idea of how it's used. This is kind of a basic use case for MN. So here I'm launching this linear type topology template. It's a chain of switches, each with one host connected to it. And I want basically to the specified number into the arbitrarily long chain. And I want to run this test called ping all, which just kind of has all the hosts in your network ping each other. So when you run that, it kind of starts off saying we're going to create a network by adding a controller, adding links, so on and so forth. And it runs the ping test, and then it just tears it down, tears topology down, and then you kind of just report how long it took. So in this case, you don't really get a chance to do any fine-grained things with your topology. So that's when you kind of specify the test argument and instead drop the CLI. So in this case, I'm still launching the same linear topology. I'm suppressing the output there, so that's what the velocity flag is. But if you run just by itself without the test argument, you get that Mininet prompt. The prompt, like the CLI itself, also has a set of different commands that you can run. So in this case, I'm taking down the link between S1 and S2. So there's S1, S2, and S3 in this case in chain. I'm running the same test, and each test also has a corresponding command. And you see that some of the things don't fall through, so I'm like, okay, I have to bring that back up. And then I'm sort of just going, okay, I just want to test between H1 and H2, so I'm actually running a command from the H1 host and seeing that the thing passes through. So each of these, so MN has several different arguments, but each of them can be omitted because it falls back on the same default. So if you don't, say, specify a topology, you'll get this very, very tiny network of one switch with 2 hosts and 1 controller. In terms of creating your own scripted topology, so in this case, I'm kind of doing the same thing that MN would do without a topology specified for it. So I'm creating this tiny network of 1 switch and 2 hosts linked together and attaching the CLI to it. So if I take this script and save it and just run it like any other Python script, I'll get the CLI, and that CLI has the same capabilities and functions that the one that MN starts. So here I'm taking it and then running the notebooks and seeing that, okay, I do have 2 hosts and 1 switch and 1 controller, which it automatically started for me. Because it basically assumes that I want to run a SDN-capable network. So it automatically starts OpenFlow enabled switches and controllers. And I'm also listing the links. In terms of running commands, there's 2 different ways to do it through the API. One is the CMD method, which lets you run a command in the context of a host. So the last H1 ping command can be kind of done it the same way by saying h1.command and then the ping the string for that. Or I also have the virtualization method, which lets you run commands in context to the host running Mininet, so the whatever's running it. In this case, I'm kind of doing another tiny topology. Okay, I forgot to mention, defining a topology is considered using a high-level API. So Mininet defines several different APIs. So the high level will be dealing with the topology as a whole, so you actually have this topo object. In this case, I'm using the mid-level API, so I'm defining these network objects like hosts and links. But after I do that, I'm running a simple HTTP server in H2 and fetching a page from it from H1. And then just as a contrived example, I'm saying, okay, I want to see all the interfaces involved in this, so I'm going to run IP-link to list out all the commands. So this is examples from the original version, which only was from Linux, but hence the IP-link. So by itself, you can just take Mininet and sort of run your toy network. So it's a pretty self-contained thing that you can use to kind of learn about or play around with SDN-capable topologies. But in the case that we're trying to develop something, Mininet also gives you the ability to incorporate your components with its topology or testing against it. So if you have like a controller and it's running somewhere else in a VM, or you're running it from your IDE because your controller is based on Java, because a lot of them are, you can take a topology and say I want a remote target, so I can just target the controller that's running in a different location and start up the topology that way. Through the script, you have this remote controller object that you can specify as well. In terms of switches, sometimes people actually create topology scripts that incorporate the actual Mininet, like the real host interface, and have that interface be wired to a actual switch. So like if we had like a ROADM before at one point, there's no emulators for it, so we actually have a ROADM sitting next to a host wired into it, and then that interface is included in a Mininet topology, and that's how we're testing out our controller that way. And another way that people might do is extend the Mininet API itself and create custom nodes, custom network nodes, so that you can say, I have a custom, my controller base node, or my vSwitch, have a custom switch class. And with a little bit of work, you can actually also have and then recognize your custom controller or switch as a node type that it can handle, so you have these two different arguments as well. If I'm not making sense, please just interrupt and ask questions. So the way it creates these emulated topologies, it relies a lot on the host OS's resource virtualization capabilities. But Mininet itself also has notions of different components and classes that take care of different functions. So Mininet, not the program itself, but the Mininet object is responsible for kind of orchestrating the whole topology creation, running tests, running commands and whatnot, and carrying out the topology. So that's kind of like the coordination object. It kind of looks at topo, which is the representation of the network, which in turn maintains a graph of nodes, ports, and links. Each of those components themselves are also different objects. In this case, node actually ends up being a interactively running bash in a Linux network namespace. So a network namespace is kind of like its own virtual network stack. Multiple of them can coexist within the Linux kernel. And programs can be started to run against that network stack, so we can only see whatever that includes. So like address space, different interfaces, routing tables, firewall rules, those kinds of things. Indexes are basically virtual interfaces, and links are finally just two pairs of virtual interfaces, create links between the nodes. Switches and controllers are just specialized nodes. So basically, because a node is just a batch, you can just run arbitrary commands. So in this case, a switch is basically a node that's in charge of configuring one instance of a switch. And a controller is just a node that's started a controller process. And again, Mininet has notions of like same defaults. So in this case, if you don't specify a switch class, it defaults to OpenB switch. For the controller, it defaults to the Stanford grounds implementation of an OpenFlow controller, which I think is a pretty old version of OpenFlow at this point. But if you don't want those, you can also specify which other custom class you want. There's a few that's kind of prepackaged with Mininet by default. So to kind of try to make everything come together, like this is kind of the output that and then we give you if you were to start the baseline topology with the one switch and two hosts, and then kind of just replace some of the verbose output that it has with the corresponding commands that are being run. So mnexec is actually just a wrapper around the 7S syscall that Linux has for associating a thread with a namespace. So first it starts off by creating all of the network nodes. So for C0, H1, H2, and S1, it would just run this mnexec thing and start a batch process. After the nodes are up, it will just run IP route 2 commands, so IP link, to create the various links that are between the nodes. After the hosts are configured with IP addresses, it finally starts up the controller and switches. So in this case, it starts up the reference controller, the C0 node context, and then it starts one switch and points it to the controller. And after that's done, it finally gives you the Mininet prompt. So the stuff that I kind of ran through is basically just a subset of all the features that MN has, and it's just a subset of examples of different scripts that you can kind of create. But that's kind of the base components of Mininet that are probably most interesting to a developer working on some SDN component. So that was kind of like my initial goal was, okay, I'm going to choose a subset of features that I want to work on OpenBSD, so those are going to be the ones that I want. I don't technically have to have switch key or switch-based custom nodes, but it would be nice to kind of have everything prepackaged, so I wanted customized nodes for those. And because I wanted to eventually upstream what I have, I couldn't just simply yank out the Linux-specific features. So I still wanted to be able to run or install it and run on Linux even after I had added OpenBSD support. So kind of taking a step back, at the end of the day, if you want Mininet to be able to run on your OS, there's a handful of features that you need, although each of them are kind of not small or simple, I guess, but you kind of need something that's similar to network namespaces. So basically, network address virtualization capabilities from layer 2 up. You also want these switches and controllers that you can use for your network nodes. You would want them to be SDN-capable, or else it won't be an SDN emulator. And then finally, you need something for the baseline tests. And iPerf is available in ports. We also have switch and switch-D for OpenFlow support. And for network virtualization, we have rdomains. So just kind of as a quick recap, rdomain and care. Rdomains are also called routing domains at times. So it's basically exactly what it is. It provides separate network address spaces that can coexist within the kernel. You can also attach interfaces to them. So if you have two different rdomains with interfaces, each of the interfaces can have the same IP address, and that's a legal thing to do. And you can also run processes associated with an rdomain so that they don't use that address space. And pair is kind of like VFers, so it's a virtual Ethernet interface, but it's designed to be used in pairs, as its name suggests. And they can also be made into virtual links, and each of the endpoints can be attached to different rdomains. So with that kind of thing, is a node just sort of translating from what's being done on the Linux side. A node ends up being a K-shell instance running in a routing domain. A switch would just become a switch instance that's being managed by one node. A controller would be a node running a switch D instance. And basically links would, instead of being VF interfaces, would be pair interfaces. Just to have a more clear side-by-side, this is sort of like a table for what each component is for Linux or still OpenBSD and what's being used to configure them. So it's kind of like a one-to-one, I guess, side-by-side. And I guess with the switches versus bridges, I just kind of forgot to elaborate. When you have an SDN, you usually have not just all fully OpenFlow or SDN-capable switches. Will have mixtures of like legacy devices that might not understand your control protocols. So you also want to have some kind of a baseline classic switch node. So that's what the bridge is in there. And kind of just going back to the same sort of what kind of commands are being run. For node creation, I would use route.exec with a -T, which is for giving a routing domain. I'm starting, like bash, I'm starting K-shell interactively tagged with a name that's used to sort of track which node it's being used as. And then I'm just kind of configuring pairs of pair interfaces, moving them into the correct routing domains. And then I'm kind of doing the same thing, configuring the host, assigning them IP addresses, which Mininet, the class which orchestrates everything, kind of just auto-assigns. I'm also having the each of the node class itself from Mininet, kind of keeping track of the routing domain IDs that are being allocated for each of the network nodes. And then I'm finally starting a switch D instance and then starting a switch. And that kind of brings us back to the CLI at the end. So before I was able to kind of just add in the OpenBSD support, I kind of had to do a lot of refactoring because in the original version of Mininet, the node and indef classes were literally just tied to specific Linux commands for creating network namespaces or creating virtual link pairs or interfaces. So I kind of had to refactor and factor out all of the portions that are specific to each of the platforms. So what I ended up with were base node and base indef classes that were the base classes for each of the OS-specific node and indef. So once that kind of was done and each, like I had custom node and indef objects, I didn't really have to change anything else above it. So the Mininet mid-level API above, like the CLI or the total class for Mininet class, I didn't have to really touch at all because they just work at the level of the node object or the order link object. So I would be able to just kind of run the same sample Python file from before, and then I can run certain commands and everything will look the same until I have to run a command that sort of scrapes the world, like the lower level information. So dump is one of those commands that would give you, okay, these are the specific classes that I'm using to build my network. So in this case, on Linux, IF switch would be OpenB switch, and switch D would be controller. So that's kind of where the differences would show up. I guess I also did touch MN so that I can say dash dash switch equals IF switch and controller equals switch D. So that was like a very minimum change. So originally when I kind of said that I was going to try porting Mininet over to OpenBSD, the primary maintainer was like, oh yeah, that should be pretty simple because everything's just shell scripts and, you know, commands just being called from Python. It'll be a weekend, you know, whatever. But it's not. It never goes that smoothly. So one of the things that were probably weirder in this case was seeing how CMD actually figures out when a command is done running. So originally, it would replace the shell prompt with a sentinel character, and it would run the command and watch for that sentinel character again. That's how it knows, oh, it's done. That's just how it was done. I don't actually know the reason why it was done this way, but so, and then the other part of this is because I think you need to be root to run commands in network namespaces. So Mininet is just started as root. So if you say MN as a non-root user, it will just actually yell at you and exit. You need to be root to run. So those two things kind of came together in an interesting way. So the particular version of K-shell on OpenBSD apparently enforced that when it's running as root, the prompt needed to include a hash or a pound character. And that apparently prevented the sentinel from being discovered, and it would cause and then to wait forever for that command to complete. So at first I thought I was going to like hack around it in Mininet, but it turned out that the behavior for K-shell prompt was different from Linux and FreeBSD, I think. So K-shell ended up being the one that was patched, which was kind of an interesting experience, at least for me. There are also just plain assumptions about what's visible in a namespace or a node. So kind of trying to run, you know, H1 ifconfig, you would expect just the interfaces on attached to that host to be visible if you do that. But with rdomains, you can still see all the interfaces that are there. So the network virtualization aspects are slightly different, but it's assumed that it would have a Linux namespace-like quality, so you'll still have some kinds of side effects like that. Also, the interfaces, Mininet likes to rename them so that they can keep track of where the interface ends up and what part of the topology. So it would say H1, E0 for the first interface in host 1 or S1, E1, and those kinds of things. So in order to do that, I ended up kind of creating a map between what the system considers the interface's name, so pair 0 to H1, E0, and had Mininet kind of use that instead. And finally, topology startup order. I was trying to start up so I was trying to run route exec when there was no rdomain present because I didn't have any interfaces being created before nodes were. So I ended up just having another kind of dummy interface as part of an rdomain before I just started a K-shell. So currently, what I kind of sort of went over is like base features are already there, except for all the bugs that I introduced, so I'm trying to slowly fix that. There's just a lot of features, and this is something that I've kind of been working on as a hobby, so there's just a lot of things that I haven't managed to get around testing. There's definitely certain network objects that I need to translate over from what's being done in Linux. So for example, I have CPU limited hosts for modeling kind of restricted, like constrained networks. So those definitely use C groups. I might also have links with traffic shaping, which use TC and IP tables. So I can maybe use PF for some of that, but I haven't managed to look at that. There's also a ton of example scripts that come with Mininet if you download it. And rather than having documentation on how to do to write your own test scripts, there's like a bunch of scripts that people tend to just sort of look at to create their own. Those are also more being tested. And it would also be nice, currently I only have the switch-D node and the switch node for the controller and a switch, but in the original one I can also choose between different controllers like Ryu, Nox, Pox, and I also have different kinds of switches other than OpenB switch. So those are only a matter of porting them over. I guess only is kind of, yeah. But it's also nice if I don't have to run as root all the time. But that would actually be kind of an improvement upon the original tool. And because I have to make so many different, so many changes to refactor it initially, upstreaming is still kind of a challenge. In terms of availability, I do have the port at Mininet. It was imported in 2017, so it has the base features. That port in particular was based off of the GitHub fork I have there, which also actually supports FreeBSD alongside Linux using the image jails. I guess acknowledgements. I guess I'm really early with this. I wouldn't be here talking about it, or wouldn't have even thought about submitting a talk if it wasn't for a few people here. Bob Lanz is the developer. He was for Mininet. He had been wanting to have it ported to other platforms for a while now, but he hadn't really gotten a chance to, so I apparently hijacked his to-do list on that, and Rick and Kazuya, I kind of bugged them about how Switch and switch-D were designed and how certain features were implemented, because they were actually kind of, they have a very different feel from what's already around and sort of popularized, which are mostly derived from OpenB switch and say, there was this controller called Beacon, which is what most Java-based controllers are now derived from. And by the way, Peter Hessley kind of gave me this really fast crash course on how to create a port and to get it imported, and he was massively helpful in just being a mentor and kind of nudging me to talk about this. So I guess with that, I'm done really early, so if anyone has any questions. I can also try running it and see if that gives a better idea, but.
In terms of the nodes, is it possible to introduce the concept of logical ordering in operations? So, for example, I could start one host, and then after that start another host, and then after that start a third host, so that we can control the sequence of events in which things occur on the network.
Yeah, that would be possible. So I'll be consecutively adding hosts saying at host H1 at host H2. So it's just going to be, like, it's not threaded, like it's not multi-threaded or anything, or nothing's really done in parallel because it's actually pretty primitive. So if you write a script that starts a host in a certain order, it will only start in the same order. Originally thought that this slot was going to be 45 minutes, so I kind of ended up with 26 slides, so that's why I'm sort of done so early. I guess that sort of gives a break for at least people who are here. Yeah. let's see if I can just pull it out. So, and then it kind of comes with a ton of different things. That's another thing that I need to do. I still need to clean up and get rid of some of these things that aren't supported. For example, that OBS type of thing. But so if I say post, let's say I want to start a tree that is 3 deep and with 3 fan out each. We just kind of start everything up in order and just give names to each of the nodes. And now if I say links, we just kind of list out all of them. Let's see. The CLI itself also comes with several different things you can do. I guess you can just like list down elements. You can like the ping on, ping off, all those kind of things are all text. You can also actually run commands or strings of Python. I think I've never really used those features. I think a lot of these were kind of just thrown in when it was being initially developed at Stanford, because back when they were doing the open flow research and development, they were kind of looking for different tools. And I think someone started off by running like 4 VMs to emulate this little tiny network, and their laptop was kind of dying, and then they're like, Linux has network virtualization features, so let's kind of try to move to that, and that's kind of where Mininet started. So it also has some weird commands in there. If I say all, if I can spell, that would just kind of ping everything. Well, actually, I should just say, so if I say to see what nodes are running, most are just, literally just K-show instances, and I have a couple of IF switch instances, and then there's one controller at the very bottom. So you can see which PIDs they are, which ports are associated with which, what is it called, switch. To kind of look at the side of things. Sorry. The one in from here. There is. Yeah. So those are kind of just automatically started by MN. And I think if it was a script, it would always be done in the same order for everything. Here, and then it just also assigns data path IDs, because OpenFlow has notions of these IDs to keep track of the different, or rather, it has notions for controllers for keeping track of the switches that it's managing. So that's the unique identifiers. What else can I show? If I do so these are all of the interactive K-shell instances that were started for each of the nodes. I guess I don't really have more to show right now, but currently I can just sort of start up these networks, sort of just manipulate them, play around with them. So if I say, I can also do hyper. I think it just, takes 2 different random hosts and runs an hyper session across them. But it's not a very high number. Anyways, that's kind of Mininet and SDN and kind of everything kind of rushed through in a nutshell, I guess. I don't have anything much else to say. So we just cleaned up after itself and shut it down. So now it's just my regular prompt. And I'll just be around, so if anyone wants to kind of ask me anything about it or something, I'll be, just kind of wondering.